Welcome! This is Precalculus 1, and today we'll be talking about the basics of analytic geometry. Analytic geometry is defined by Merriam-Webster as the study of geometric properties by means of algebraic operation upon symbols defined in terms of a coordinate system, which is also called coordinate geometry. Using analytic geometry, we can find the measurement of conics. The conic section is an intersection of a plane and a cone. This can produce a circle, a parabola, an ellipse, or a hyperbola. Given the fundamentals, let's take a look on one of the use of analytic geometry. We have Kyle, who was assigned to create a blueprint of the lantern of a lighthouse. The pair of light bulbs of the lantern must be placed in a coordinate 60 cm from the center of the lens of the lantern. The lens of the light bulb is placed 10 cm behind the bulb, and the other one is the same measurement at the opposite direction. Where should be the location of the other light bulb and the center of the lantern? The light bulb are the foci, the reflectors are the vertices, given the following. First reflector is at coordinate -50 and 6650. The second reflector is at coordinate 50, 6650. The second light bulb is at coordinate 60 at 6650. We need to find the following. Transverse axis, the first light bulb. The conjugate axis, the asymptote, and variables a, b, and c. Given the hyperbola formula is x minus h squared divided by a squared minus y minus k squared divided by b squared is equal to 1. Asymptote formula of the hyperbola is y is equal to k plus minus b divided by a multiplied by x minus h. Given the vertices of the hyperbola or the center of the reflectors in this regard, we can find the center of the hyperbola using the midpoint formula. X is equal to 50 plus -50 divided by 2 is equals to 0. Y is equal to 6650 plus 6650 divided by 2 is equal to 6650. Center at 0, 6650 coordinate, which is h and k respectively. Given the center, find the distance from it to one of the vertices. A is equal to 50 minus 0 is equal to absolute value of 50. Or A is equal to 0 minus 50 is equal to absolute value of -50. We can also find C given the position of the foci and the center. C is equal to 60 minus 0 is equal to 60, or 0 minus -60 is equal to 60. For given the values of A and C, we can use to derive the Pythagorean theorem to find B. B is equal to square root of C squared minus A squared. B is equal to square root of 3600 minus 2500 is equal to 33.16. The asymptote can be already computed given the values of A and B. Thus, y is equal to 6650 plus minus square root of 3600 minus 2500 divided by 50x. In summary, we have the following. Center of the hyperbola at 0, 6650. A is equal to 50, B is equal to 33.16, C is equal to 60. Transverse axis horizontal, because the hyperbola is in horizontal opening. Asymptote with an equation formula function of y is equal to 6650 plus minus square root of 3600 minus 2500 divided by 50x. And the final equation of our lighthouse problem will be x squared divided by 50 squared minus y minus 6650 squared divided by 33.16 squared is equal to 1. And that is one of many uses of analytic geometry in real life. Thank you all for watching and have a good one.